You can see the high reflector mirror here, which is a combination of O-ring compression and steel washers. I drilled holes radially around the diameter, the circumference of the washer 120 degrees apart, and that way I can adjust the mirror and squeeze compression on these O-rings so that they form a seal. And the tube altogether is about 5 feet long. The glass part of it's about 4 feet. This is a plastic fluorescent lamp protector, the kind of tubes you put around a fluorescent lamp in order to keep them from shattering in case of impact. And you can see it's flexible, it's soft. But inside that is a long, slender tube. It's like a neon sign glass tube. That's somebody gave it to me. It's what they use for neon signs. And it extends along here with water in there to cool the thing down. So it's really a very simple device. It's kind of like a neon sign with a water jacket around it and mirrors on the end. The only thing is the mirrors do have to be special mirrors because it has to transmit a wavelength that's more like radio waves than light. And as you can see, this is the output coupler, and it's got the same identical washer O-ring compression device as I have on the other one. And so you can see the 3 adjustment screws. There's a lens ZNSE zinc selenide or zinc selenium. I'm not sure how to pronounce that. It's a special material needed to transmit this wavelength. So that's the lens used to focus the beam onto the target. The device I made, it's a lot of JB Weld, and you've got a needle valve right here, and you've got a balloon up here. So what I do is I mix baking soda and vinegar, and I shake them up in a bottle, and then I turn this valve on and I let it fill the balloon part way. Then I put some helium in the balloon using this little Walmart brand party helium mix for party balloons. You can get those at Walmart. And the nitrogen is from the nitrogen comes from a little tank that I have that is actually used for my nitrogen laser. So I have a real tank of nitrogen, but it's a small tank. But anyway, when you eyeball these 3 gases, mostly helium, a little bit of maybe 10% or so. I'm just going by eye. 10% nitrogen and 10% CO2. Then you can have a sufficient mix for a laser. You turn the power on. I put this big red light up there for a pilot lamp to prevent, so I'll know that the power is on. And when I turn it on, you get a glow discharge in there, but of course you don't get a beam without the gas. And the beam is like radio waves. I mean, you can't see it with a normal digital camera like you can with near-infrared wavelengths. It's way out there. Normal glass and plastic and stuff that's transparent to regular light completely blocks this. So I open the little needle valve here till about 1.5 on this little adjustment. Oh, there we go. That's a piece of glass right there. It appears to be doing some damage to it. Sorry about the focus here, but okay, let me turn that off. I'm not looking directly at that. You can see it made a little spot in it, maybe a hole, I'm not sure. Small changes on that needle valve make a big difference. Had to make some adjustments here. Let's see. There we go. Now there we go. I'm getting a nice flare up right now. I don't know if I can make a hole through that or not. Pretty good performance though. There we go. Alright, enough of that. It wouldn't go through that, so let's see if it'll go through. It wouldn't go through all the way. Let's see if it'll go through a microscope slide. Might, who knows. And I'm watching this through the camera. I'm not looking at it in person because it's kind of like a carbon arc. It's pretty intense. Real small point source. Okay, here is a tiny hole through the microscope slide that the laser made. So that worked. Microscope slide's thin enough to where it went through it in a reasonable time. So that's it. Made a hole right through that glass microscope slide or silica or whatever it's made out of.